First, we will introduce the sets. Thereafter, we will learn about the concepts, representations of sets, types of sets, subsets, Venn diagram, operations on sets, and applications of sets. At the end, we will summarize all the concepts discussed in this module.
Introduction to sets. Here we observe some objects: table, chair, and bed.
We can represent sets in the following two forms.
Introduction to sets. Here we observe some objects: table, chair, and bed. These three items make a collection. Do they belong to any particular group? Yes, these all are collectively called furniture. Here we see that table, chair, and bed are a well-defined collection of objects, which forms a set furniture. Thus we can say that a set is a well-defined collection of objects. Now, let us form one more set. Can you tell the name of this set? Yes, it is bird. See, some objects are left behind. Do these objects form any set? Yes, these all are monuments, and we can name this as a set monument. Hey, see what the queen is doing. She is removing all her jewelry items and putting them into the jewelry box. Here, the set is the jewelry. The ring, bangle, earring and necklace are the elements of the set jewelry. To represent in short, let us denote set jewelry by capital letter J and its elements, the ring by R, bangle by B, earring by E, necklace by N. Thus, we can represent set jewelry as shown. Note that this symbol used to denote the phrase belongs to, and this symbol is used for does not belong to. Here, R, B, E, and N belong to set J. Suppose H represents hand, and since it is not a member of this set J, thus symbolically it can be represented as shown. Keep in mind that the set is denoted by capital letter, whereas elements are denoted by small letters. Now, let's see some examples of sets used particularly in mathematics. Set M represents the set of all natural numbers. Z represents the set of all integers, and R represents the set of all real numbers.
We can represent sets in the following two forms: roster or tabular form and set builder form. Let us first know about the roster form with the help of following animation.
Wow, what a beautiful rainbow it is! Can you name the different colors in this rainbow? Yes, we see violet, indigo, blue, green, yellow, orange, and red colors in this rainbow. Let us denote these 7 colors by V, I, B, G, Y, O, and R respectively. Now, arrange these colors in a curly bracket separated by commas. Let us denote this by set A. This form of representation of a set is known as tabular form or row roster form. Thus, in roster form, all the elements of the set are listed within the curly brackets and they are separated by commas. Roster or tabular form. In this method, a set is represented by listing all the elements of the set. The elements are separated by commas and enclosed in braces. Example, A is equal to, braces begin, January, June, July, braces closed. There are some limitations for roster form. In roster form, each element of the set must be listed exactly once. Generally, repetition of the elements is not allowed while writing a set. For example, the set of all vowels in the word institute is braces open, I, U, E, braces closed. In roster form, the order in which the elements are listed is not important. Which of the following sets represents the roster form of the set A, which consists all the consonants in the word Thiruvananthapuram? Set builder form is a formal convention for specifying a set in a mathematically concise way. In this form, a set is described by stating a single common property of its elements. In this form, a variable followed by a colon is written to denote each element of the set. Then, after the sign of colon, the characteristic property is written. Then the whole description is enclosed within braces. Example, the set of all natural numbers greater than -5 and less than 5 can be written as shown.
Which of the following sets represents the set builder form of the set A? Click to know the correct answer.
Now, we will learn different types of sets such as finite set, infinite set, empty set, singleton set, and equal sets. See, these players are ready for their matches. Let us name team of football players as set A and team of basketball players as set B. Here, we can see that both the set have definite members. So, these types of sets are called finite sets. Thus, a finite set is a set that has a finite number of elements. Can you count the number of stars in the sky? Of course not, because there are infinite number of stars. So, the set of stars is an example of infinite set. Thus, an infinite set is a set that has an infinite number of elements. A set of days in a week is an example of finite set, whereas a set of natural numbers is an infinite set. Let's have some fun with cricket. In a particular day of cricket practice season, 3 famous batsmen, Brian Lara, Sachin Tendulkar, and Ricky Ponting are practicing. Let us make a set of these 3 batsmen. Name it set C. Now from a given set C, can you make a new set D, whose element has the starting letter K? As we are trying to find out whether Kevin Peterson is present in the set C or not. Yes, you can make a set even in the absence of an element. Since there is no such member present in the given set C of batsmen whose name starts with K, so there will be no member in set D. Hence, it is a null set. Thus, we can say a set which does not contain any element is called an empty set, or null set, or a void set. The empty set is denoted by phi, or empty braces. Here, M is the set which includes male players and F is a set of female players. Here, both the sets have same number of members. So, these sets are called equivalent sets. Thus, two sets are equivalent if they have the same number of elements. Now we have a set of prime numbers less than 6 and a set of prime factors of 30 shown by P and Q respectively. Here, both the sets have exactly the same elements. So, these sets are called equal sets. Thus, two sets P and Q are equal sets if they have exactly the same members. Each element of P is in Q and each element of Q is in P. The order of elements in a set is not important. The flower pot has a definite number of flowers. So, the set of flowers of this pot is a finite set. A set. There are infinite number of stars in the sky because the universe is infinite. So, the set of stars is an infinite set. A set that contains infinite number of elements is called an infinite set.
Here are some examples. The set of all x such that x is an integer greater than 1 and less than 10 is a finite set. The set of all x such that x is a multiple of 3 is an infinite set.
Let us try to make the set of white roses belonging to this group. Since there is no white rose in the group, the set of white roses is represented as phi, or empty braces. A set which does not contain any element is called an empty set. An empty set is also known as a null set or a void set. A null set is denoted by phi or empty braces. For example, the set of months with 32 days is an empty set. If a set A has only one element, it is called a singleton set. Let us observe the following three sets of flowers. Set A, set B, set C. What do you observe? We observe that every set has exactly the same type and number of flowers. Therefore, all the three sets are equal. So, we can write set A is equal to set B is equal to set C. Two sets A and B are said to be equal if they have exactly the same elements.
Here is an example. Two sets A and B. Rohan, Sarita, Arati and Dhruv in set A and Sarita, Rohan, Dhruv and Arati in set B. Since A and B contain exactly the same members and the number of members are also same, therefore A is equal to B.